Okay, got a little bit of overunity with a resistive load this time. I have a 150 ohm resistor across a 30 UF cap, and I also hooked up in parallel a 20 UF cap. So it's 50 UF cap, 150 ohm resistor across it. Okay, it's getting hot too. And so it's making power. And I'm not doing the inductive load now. The inductive load, it's always like 2 up to 3 times more out than in, apparent power out. Anyways, I did, right now, output is 20.23 amps and 12 volts is the output into the resistor and the cap from a secondary of the two secondaries are in series, and the output is the power out, and that goes into that cap with a resistor across it. It's 50 UF, 150 ohms. Okay, input is 160 milliamps and 16.6 volts from the Variac. And I did a lot of tests last night, and this is like I was saying, 50 UF cap, 150 ohm resistive load. And at 10.3, you see what I did is I went up in voltage, 10.3, 12.11, 13, 14, 16. I just cranked up the Variac 3 or 4 volts at a time, you know, 2, 3. Anyways, so this is the voltage and then the amps. And there's the in and the outs. So what this, it's a step down. It's always like 10 in and 7 out, 12 in, 9 out, 13 in, 9 out of voltage. Okay, so it's kind of a step down voltage transformer. See, 22 to 16. These ones, these top 3 here, I got overunity by a little bit on each of them. All of these were like just about even Steven. And how I got it, and you notice it's the, like here's the in amperage, 0.09, out is 0.13. Let's go down here, 0.14 in for amps, 0.20 out. So the overunity comes from more current output than input. It's always more current out. So what I have the numbers right now is 16.6 or whatever, 17. And that's this one here. And it's 2.6 in, 2.7 out. This one's 4.9, 5.1. So the way when I started out, you know, last week, when I did resistive load, it was like 20%, you know, 5 watts out. 5 watts in, and so you get like 2 or 3 watts out. So it's like, oh my God, it was horrible. But what has changed things is these shunt bars pulling the back EMF into the opposite secondary. when I wrapped these around there and then shorted them out, it made that draw really go down in the input, which means to me that it is really working. The back EMF is being guided around the primary. It's not going back into the primary. Some of it is, but most of it is not. And when I did these shorted out coils, it made it so it's a stronger magnetic force it wants to follow out here. I guess that's why. So what I did though is when I had a 30 UF cap and not adding the 20, I wasn't getting over unity. That's this page here. This is a 30 UF cap with a 150 resistive load. And you can see here it's like in is 22. I don't know. That one was in, out. Oh, here. I'm looking at the amps. Here's the watts right here. So this one's like 5 in, 4 out. 7 in, 5 out, 8 in, 5 out. So it wasn't getting over unity when I had a 30 UF cap. But when I added the 20, so it's a 50 total UF cap, now I started getting even Steven and a little bit over unity. Here's a 9.6 volts in and 0.08 outs, and I get 6.6.12. So the watts were in were 0.768 and watts out were 0.792. And so that's like because I have a 50 UF cap. So I think I can do much better if I can put like 80 UF cap. That's what I'm gonna do now, is increase the cap UF value. And I think it's gonna have more and more current going through with still the same ratio of volts. So adding capacitance made it jump up to the over unity and even Steven ranges, which is good for a transformer. And this is a resistive load. Inductive load, it's like way over unity all the time. So, but everybody wants to see that resistive load, so I did it. Okay, guess that's about it. Thanks for watching again. Okay.